Alright, so now that we know what an atom is made up of, which is the nucleus and the electrons are in the electron cloud, now let's study about what is the most important thing in an atom's that defines the atom's main identity. So now we introduce the concept of an atomic number and a mass number, right? So what is the most important number that defines the identity of a particular element? Now, the number of protons in the nucleus of the element of the atom is the most important thing that defines the atom's main identity. That is the only thing that defines the atom's main identity, right? And that thing is called the atomic number and denoted by the letter Z, okay? Now, it is denoted by a subscript to the element symbol, right? So carbon has an atomic number of 6. That means carbon has 6 protons. Nitrogen is defined, but it has the atomic number of 7. That means nitrogen has 7 protons. Okay? Now, even if I do not write nitrogen, it already means that the atomic number is 7. If I write oxygen, I do not have to specify the number 8 here. Even if I don't specify the number 8, people will automatically know that the oxygen will have 8 protons, because it becomes oxygen only when it has 8 protons. It becomes carbon only when it has 6 protons, right? So that means the number of protons in the nucleus is the most important factor that defines the atom's main identity. Okay, now why not say the atomic number is equal to the number of electrons? Because electrons can change. The number of electrons in an atom is not constant, but the number of protons is, and we'll see why. Why the number of protons in an atomic nucleus remains constant while electrons change. But for now, we have to understand that since electrons change, we cannot define an atom's main identity by the number of electrons. It has to be something more stable. It's kind of like fixed, right? So protons are fixed, and that's why we define the atomic number. In the periodic table, all the elements are actually arranged in an increasing order of the atomic number. So you have hydrogen, then helium, lithium, just like goes from 1, 2, 3, and increments all towards 118. Okay? So, what is atomic number? The number of protons. Now, there's another concept, which is the mass number. What is a mass number? It's the number of nucleons. What is a nucleon? The nucleon is the number of protons plus the number of neutrons in an atomic nucleus. Okay, so you have carbon, so you have 6 protons, and the protons is 6, which is the atomic number. 12 is the mass number, and mass number is the number of protons plus neutrons. So, if the number of protons is 6, and 6 plus the number of neutrons make 12, what's the number of neutrons? Simple, 12 minus 6, right? So same goes for nitrogen. So the number of protons is 7. Number of protons plus neutrons makes it 14. So number of neutrons is 7. It's a very simple concept. The number of protons plus neutrons is the nucleons, which makes the mass number. Now, we will see how atomic number gives that element its identity while the mass number can change. We'll read about this concept in periodic properties, in which how a same atom can have different mass numbers, and we'll study what they're called. If you already know that, you can shout out loud, and I will be able to hear you. So yes, right, you're right. It's called isotope. Okay, so we'll be studying about isotopes later. Okay, now remember when I said that the number of protons cannot change? So the number of protons cannot change. Why? It's because the nucleus is extremely stable. So any atomic nucleus is very stable. So it's very hard to change the number of the identity of the atom to change the number of neutrons and protons in the nucleus. You cannot change it. For all chemistry, the nucleus is stable. The only time that nucleus changes is when you get into the domain of nuclear chemistry, which we are not dealing with right now. But that is the only point where you can actually change the nucleus of any atom. For the chemistry purposes, the nucleus is extremely stable. That means the number of protons and the number of neutrons do not change. So, if it does not change, then the number of protons remains fixed. The number of protons remain fixed. You cannot change them. So basically you can't change the nucleus. It's a very sad day for the alchemists, because the early alchemists, what they wanted to do is change everything into gold. They wanted to take, they were trying to find out ways in which they can get anything and convert it into gold. For example, they wanted to take carbon, graphite, and turn it into gold. They wanted to take iron and turn it into gold. They were unsuccessful, and now you know why. Why? Because to change an atom into a gold atom, you need to change the number of protons in the nucleus. Now you tell me, is it possible? The answer is no, it's not. And therefore, alchemy is not possible. It's a sad day for the alchemists, but we at least know that why it's not possible, right? Now, there is a concept called the binding energy, and this is the reason why you cannot change the number of protons and neutrons. It's stable, the nucleus is stable, but why is it stable? Now, a very important concept in chemistry is the relationship between stability and the energy. Now, anything that has more energy is less stable. Anything that has less energy is more stable. Like a toddler, he or she has extremely high energy. They roam from place to place, but they don't have that stability. When you grow old, you lose that energy in exchange for stability. It's the same thing. Nucleuses are extremely stable because they have given up a huge chunk of an energy that was inside them called the binding energy. When the atom released that binding energy, they got stabilized. And that's the reason the nucleus is extremely stable. Now, what is a binding energy and how do you find it? Now, a very interesting point, that the mass of the nitrogen nucleus should have been the sum of the protons mass and the sum of the neutrons mass, right? It has 7 protons and 7 neutrons, and we know the masses. We could have just calculated the mass, and that should have given us the mass of the hydrogen of the nitrogen nucleus, right? I can guarantee you, if you measure the actual mass of that nitrogen atom, you will find that it is less than the sum of the 7 protons and the 7 neutrons. Wow, how did that happen? It happened because that difference in that energy, the mass difference between the nucleus and the sum of the protons and the neutrons was released as energy. So there was this mc, E is equal to mc square. We all know this is a very famous equation given by our own Einstein. So he said that if you want to convert mass into energy, you have to multiply by the c squared. Like c is the speed of light, right? So you convert that mass into energy. So this will be a huge number. So the nucleus reduced its mass and released that energy in terms of the binding energy, thus reaching stability. That's what it did to gain stability. It took some of its mass and converted it into energy, and that's what made it more stable. And that is why changing the number of protons and neutrons in an atom is extremely difficult. It only happens in a very small part of chemistry, which is called the nuclear chemistry, We'll study about those, but for now, we have to understand why the nucleus is so stable. It's all binding energy. Now, you cannot change protons, you cannot change neutrons. Okay, it's boring. So what happens to the atoms? Like does it just sit there? No, it reacts. What actually reacts and why does it react? Because there is another thing that can change, the electrons. The electrons in the atom can actually move. Now, an atom can get more electrons, lose more electrons, and it can do many different kinds of things. And this brings us to the next concept of ions, in which you have there is an exchange of electrons in which the number of electrons and the number of protons do not stay constant. They can change, right? So, say you have a carbon atom, so it has 6 protons, and if it is neutral, it has 6 electrons to counterbalance the charge. But carbon can get 1 electron, lose electron, and can be positive charge if it loses. So the number of electrons decrease by 1, so there are 5 electrons left, and there are 6 protons, so it gets a positive charge, and the reverse can happen if there are, like if the carbon atom gains electrons, right? So when an atom gains electrons, it becomes negatively charged. When it loses electrons, it becomes positively charged. Why? Because the number of electrons and the number of protons do not remain the same.